All right, here's a video of a ball being thrown up in the air. It's recorded in super slow motion. Notice that the ball was moving while it was still in the hand, so it had a velocity when the person let it go. And as it goes up higher and higher and higher, the ball is moving more and more slowly. At the very top, there is an instant where the velocity is 0, and then the ball turns around and it comes back down, and it's going to go faster and faster and faster as it falls back down. This is called free fall. We say that an object is in free fall when it's in the air and nothing is touching it. This part of the unit will be looking at free fall. If we go back here, again, notice that the hand and ball are already moving, so we would say that the launch velocity or the initial velocity is not 0. And then we can also look at about when they let it go. So this is, if you look on this on-screen stopwatch, about 0 seconds was about -65. And let's see how long it takes to get up to the top versus going from the top to the bottom. So I'm going to, let's see, it's about right there. It's about 0.37 seconds. And let's fast forward through this. And then to get back down here is about 0.74 seconds. So if we, on our calculator, if we do 0.37 times 2, oh, that's 0.74. So one of the things we just learned is that the time it takes to go up to its max height or its apex is equal to the time it takes to come back down. So the hang time is the total time in the air. So starting from here when we let it go to all the way back down. That would be the hang time. And the time to go up is the same as the time to go down. So Michael Jordan famously had a hang time of 0.92 seconds. So he was in the air for almost a whole second. So we can imagine him jumping up and coming back down. What we're going to do is I'm going to walk you through a problem to calculate how high he can jump. The initial position where he starts is he's going to start on the ground, so we'll call that 0 meters. And we want to calculate how high he's going to jump, so our x is going to be unknown. Now, how fast is he going when he leaves the ground? A lot of students incorrectly say that this is a velocity of 0. But if you're going to throw something up in the air, your hand has to be moving, and therefore the object is moving as well before you let it go. So the initial velocity is not 0, but we don't know what it is. The acceleration of an object in free fall on Earth is always going to be -9.8 meters per second every second. So that means it's slowing down or speeding up by 9.8 meters per second every second. So it's going 9.8 meters, it's going about 10 meters per second faster or slower each second. The other thing is at the maximum height, Jordan's velocity is 0, okay? So when he gets that max height, the velocity is 0. We just saw that in the previous little video. So 0 meters per second. Okay, so we need to choose an equation. Let's see. Ooh, I'm writing a little big here. We'll squeeze it in. So we have our two equations. There's one of them. Here's the other. And we need to choose which one to use. Well, we want to get the final position. We don't know the initial velocity. So, what could we do? Because this has initial velocity and this has initial velocity. Now, here's the first trick that comes with these types of problems. I'm going to draw a little picture down here. So if here's the floor, here's where he jumps, and he jumps up, and he goes to his maximum height, and then he comes back down. I'm going to call this point A, I'm going to call this point B, and this point C. So what we can actually do is, because we do not know the velocity here or here, the only velocity we know is the velocity at B. And so we're going to choose to kind of split the problem in half, and we're going to start at point B and end at point C. And so all our initial positions and initial velocities will now be the position at B and the position and the velocity at B. And all our final things will be at C here. So let's update that. So our initial position is the position at B, which is unknown. And if you want, you can still write initial position, or you can just write B there. Our final position, now we know what that is. That's going to be 0 meters, because that's the position at C. The initial velocity, hey, that's the velocity at B, and that's really nice because that is 0, and that's going to simplify things. And now our velocity at C, we don't know what that is, so that's the question mark. And you might look at this and be like, well, that was dumb. What do? We changed out a few question marks. We still have 2 unknown variables. But this is now our final velocity because we're ending at point C. And this equation doesn't have final velocity in it. So that's the equation we are going to use. So we're going to start with that, and we're going to plug in some values and solve. So my final position at C is 0. The acceleration of an object in free fall here on Earth is going to be 9.8 meters per second. The time it takes, we wrote that down as 0.92. The initial velocity, the velocity at point B, is 0. That's at the max height. So this is actually going to go away because 0 times anything is 0. And then the initial position, or the position at B in this case, that's what we're going for. So we can plug that into our calculator, and we can solve for his maximum height. And I think we get something about 4 meters. Okay, calculator said 4 meters. But that's really tall. That's like way taller than our ceiling. In feet, that's like 12 feet. There's no way his shoes are 12 feet above the ground. And we actually messed something up. And I did this on purpose because this is a really common mistake that students struggle with. So what you need to do is, since we did B to C, we need to use the time from B to C. Well, this is his hang time. Hang time is the total time in the air. It's the time up and the time down. The time from B to C is just half of that, because we learned that it's the same amount of time going up and down. So we would need to redo this and divide the time by 2. So we do 0.92 divided by 2, and we'd square that. And the answer we end up getting is about 1 meter. If you're getting a negative value, you're just not completing your algebra, because you got to get these two things on opposite sides. You got to solve for the B. So we get that Jordan can jump, Michael Jordan, 1 meter in the air, which is a lot. Probably more than anybody in our class can certainly do. And this is the secret to the hang time problem, is picking a point, or like kind of half the problem a lot of times, and all your initial values, the position and the velocities go with where you're starting, and then all the final ones go with this. And then you got to watch out for the time. Now, do not think, oh, I'll just divide the time by 2 every time, because sometimes we will only give you the time to fall, and other times we'll give you the whole thing. Sometimes we'll ask you to calculate the hang time, or the total time in the air. And so you may split the problem in half and get half the time, and then you would need to double it. So that's how to do a hang time problem.